Welcome to lab number 9. So please go to Blackboard and go to this week and then download the files for today. Today we are going to learn to solve a real-world problem. A real-world problem. Because it is taken from a real-world database, a real-world website, which is Cargo. Okay, and then use some practical steps for production. Now, the steps were actually covered in last lesson when we talk about cross-validation. So today we'll be combining a number of things. We will use cross-validation, which we learned last week. Okay, and as I mentioned in the lecture, we can use classification models for regression. Okay, we are going to use something we know already, which is based on KNN. Okay, but it's called KNeighborsRegressor. And we are going to use a class called joblib, and which can help us to save the model, which is a dump. Dump 唔係抌咗佢啊. This is to save, which means to export a model, and then we can load it later. Okay, this is almost a complete cycle of what a real machine learning models in the real world will look like. Okay, because the training itself may take some time. Okay, may take a few minutes, may take a few hours. So you don't do it every time. You save the model and then use it on the new data. So this is a real-world machine learning problem using practical steps for production. We are going to use a regression model that was based on classification, in this case, KNN. So download the files, suggest you use Spider. Okay, actually any environment will be fine. And the instructions are in the comments. I'm starting my Spider here. And in the meantime, you can take a look at the data file, which is called TMDB 5000 movies. I have chosen this data file so that it's closer to your group project. I didn't use health or education data. I used a movie data. Right? So it's closer to your group project. Okay, now I think this is similar to what you are trying to predict, right? Now, these are actual movies. So now you may recognize the name, original title, Avatar. Pirates of the Caribbean, At the World's End, and so on. Spider-Man 3, okay? Now, if you look at the revenue, they are large numbers, very large numbers, okay? Maybe trillions. So we have to do something in the data preparation. I'm opening the template. This is the template. Now I'm going to save you some typing here by giving you the template. So try to complete it. So let's drop the rows with the missing values. Okay, there are many ways to do it. And I'm going to do a drop NA, okay. And I'm going to use in place equals to true. Okay, otherwise it will just return a data set to me and then I will put it in something else. So it means that I actually modify the data set here, which is called data. And then I have to create the features matrix X and the label vector Y. So how do we do it? Well, feature matrix is capital X, right? Is coming from our data frame. Okay, and let's just drop the revenue because we are going to predict the revenue. Now let's take a look at the comments more. Be sure to download the dataset from Kaggle and put it in the same folder as your program. But in this case, I've downloaded it for you, okay, and put it in Blackboard. So if you're interested, you can go to kaggle.com datasets, and you can find out more about this dataset. Actually, you can go to kaggle.com, and then you can find out some interesting notebooks and here. Okay, you can find out a lot, many interesting notebooks there. So you can try, you also use it for your group project as well. Both notebooks and dataset can be found here. Okay, so you can click code and itself, you see it can create, it's like an online Jupyter notebook. You can find some sample notebooks and then you can paste it here, you can run it here. It's very easy. Okay, but today we are not going to do that. So I leave it up to you to explore this environment. It's very useful. So again, if you go for job interviews, if you can say, hey, in your CV, you can include a link to your notebook and Kaggle, and then they can actually take a look at your notebook, which is nice, right? And you can include some visualizations. Oh, again, why don't you just include your group project here? Maybe it's a good thing. Try to stand out from the crowd. Okay, other people mention, I know Python, I know this and that. Yes, you can mention all those things, but how can they judge? How can you verify? Now, I'm not saying that this is the best way. This is a way. What I think is the best way is to earn some certificates from, let's say, Microsoft, from Google. Okay, that will be even better, I believe. Okay, but this is another way. Now let's go back to the coding. So this is the background of the coding. So 5,000 movies. Pre-process the data. Now this given to you, like I said before, the revenue are big numbers. So I divide the whole column by 1 million and put it back. Okay. Otherwise, I'll be handling these big numbers. I drop the missing values. And then this is what I'm going to do. I'm going to drop the revenue. Okay, I'm going to drop the revenue column, which is up there in revenue. So I'm just revenue. I'm going to drop it, and I'm going to drop. Now this is a name. So what is this name for? This name is for a column. So what this thing here is I'm going to drop something revenue, and this is not a row. This is a column. Okay, so I'm creating my features matrix. And what is my label vector? Well, that's easy. You just copy it. You just grab that column, right? Of course, we are not going to drop it. We are going to get something from this column, okay? So this is our label vector. And the k-fold, we talk about it in the lecture. Okay, so this creates a k-fold object. It's called k-fold. Of course, you can call it Kelvin or anything. Okay, but I'm going to just keep the name as k-fold. Okay, just to avoid any confusion. So just call it k-fold. And then it says KNN with 5 neighbors. So guess what we are doing here? We are creating a model, okay, called KNN. Now, how do I know the name should be labeled, be model? Because I'm going to use it in the cross-wall score. Okay, so I know it should be called model. So model equals to whatever we imported here, KNeighborsRegressor, right? Now, you don't have to copy and paste. You can, of course, but you just type enough keywords, KNeighbors. And then there's in this constructor, you have to specify how many neighbors. I said 5, right? Again, you just type enough. You just say neighbors equals to 5. Okay, and there's no syntax error. Very good. And then the cross-wall score, this is given to you. The root mean square error, okay. You call this thing returned by cross-wall score, okay, and then I don't know why, but it's all negative, so you have to convert it to positive number and then get the square root and put it into this variable, call this thing, okay, and then you print them out. Actually, you can copy it from here, and it should be n underscore neighbors. Okay, so I think this is wrong. This line here is wrong. So it should be like this. Okay, yes, n neighbors equal to 5. Okay. So I think we don't have, oh, and then you have to train the final model. So this creates the model, but doesn't train it. So how do you train it? Well, you say final model, you call the fit method, which you know very well by now. And then the default is X and Y. So the big X and the little y that we created in line 24 and 25. Okay, so I feel like I'm making, like a student making a video for the assignment, explaining everything. Okay, so you just print these things out. Step 6, load the model. So you save the model here. Okay, this one is for saving the model. Step 6, load the model. So how do you load the model? So like I explained before, you call joblib dot, there's a load method. Okay, and then as you can see, it says file name. And then there's an optional parameter. The default is none. So you just load whatever file name you gave before. So it was saved at this model, right? So you load this model. Now, actually, in real life, you don't put it in the same program. In real life, you don't do this, okay? Because this is for testing and learning, okay? But in real life, you don't put them in the same program. Normally, you wouldn't. Okay, and then you do a prediction on the now it says loaded model something here, okay, but there's an error, which means that this string is not defined, so I have to say loaded model equals. So now this model is defined here and there's no error down here. Okay, so when you're typing the code, you learn more about the syntax and things. Okay, so let's try to run it. Default configuration, yes. Let's run it. And it's running. And it takes a little bit of time. And as you can see, this is the output. Regressor, payful cost validation. Now, I cannot, for some reason, I cannot magnify it here. So I'm going to put it into a notepad so all of you can see it more clearly. So run it 5 times. Okay, we run it 5 times. The root mean square error. The first one, second, and so on. And then it takes the average of these values as 103 point something. And then it says it saves the model as this one. Okay, and then it runs it on some kind of unseen data. And then this the mean square error on the unseen data. Okay. Now this is not exactly unseen data because it tests it on the first row. We take it from row 0 up to but excluding first one, the second line. So we are testing on the first line. Okay, this is not exactly unseen because the X was used in the training. But anyway, we want to try it out, right? We want to try it out, so that's okay. So that's it. Now, if you look at the instructions, enter the code according to comments. We did this, run the code, look the output in the console. This output by the KNeighborsRegressor algorithm. Now note that after you run it, there's a new file with the extension .pkl. So you go to the downloads folder. See, you have a new file called this thing, right? Whatever you call it with the extension. So I call it movie revenue KNN model.pkl. And that's the file we created. Do you want to know what's inside? Well, why don't we take a look? But it's going to be garbage. It's going to be garbage. So you can open it with maybe Notepad. This one's you cannot. Notepad plus plus. Yes, it's garbage. It is almost binary, but not quite. As you can see, you see something over here, metric parameters, okay, some neighbors, and so on. But you don't have to know. This is just the model. This is just the model. And now, if you're familiar with things like ONAMA, you can download a model. Let's say ChatGPT, you can download the model, right? You are downloading model of this kind. So they train the model on almost everything you can find on the internet, movies, music, novels. They train it and they come up with one big pickle file. And then you download the file. And now you have all the wisdom that have been trained by OpenAI, Google, or whatever. But mind you, if you download something like this, it is out of date. Okay. As soon as OpenAI or ChatGPT allows you to download it, at that cutoff day, it becomes obsolete. The cutoff day may be 2024 or maybe 2025, but then you don't know anything that the model will learn after the cutoff day. Okay, but this is the same principle. Unless you download another file and train it again, and then you come up with a new pickle. Okay. Now, again, if you go to, now, are there questions regarding this exercise? It's a very simple one. Oh, actually, there's another thing we should do. Examine the content of variables and objects in the Variable Explorer. So let's do that. The root mean scores. Okay, the CV scores, basically the same thing. Okay, but these are all negative values. They are not the roots. So these are the negative values of the CV scores. And then this CV RMSE is the square root of these numbers. Okay. And this is the data, not a lot, budget, popularity, runtime, vote average. So these are the lights. So like just like in your group project, you may have some lights here, right? Some lights. And the runtime, I think it is how long has this been on in the theater? So in your group project, it's like how long that video has been on YouTube. Okay. Of course, this has to be in this of the same unit. Because in YouTube, if you look at YouTube, okay, if you have been actually working on this, you will know that they give you different times, right? Different units. So Gen AI, this says 11 months ago. So some would type just in a spreadsheet type 11. That would be wrong, okay? Because this one says 1 year. So you have to, now there are limitations because 1 year, how long is, it says 1 year. Is it 565 days, 66? So you have to make some kind of assumptions, okay? And there's no exact answers for you. You have to, if I were you, I just assume that a month is 30 days. Okay, so if today is March and it said it was posted 1 month ago and then it is not a leap year, so you have 27 days. Okay, so I think that makes things very complicated. I would just assume a month is 30 days. A year is equivalent to 12 months and so on. Okay. Now the views of pay, again, this is a round number. We never know what the actual number is. Okay, so you may just multiply by 1,000. You make some assumptions. Now this is one. Now does it fit? It fits, right? It fits the criteria. Gen AI is in it. Do you have to watch this video? Yes and no. Okay, the answer is yes or no. If I click it,
輸入 Panda Deal 慳高達120蚊，大家樂、李家、米先生。
Now you just flip through it. I think it's some kind of recording of a live broadcast. Yes. So it is a live broadcast.
To see that you have joined us, I already see that we have people from.
So this is a live broadcast.
We have the smart pricing engine where we have.
So you have different presenters, right? Same presenter or different inviting. Oh, I think it's inviting another presenter. Okay, so this format is like a conference. The presenters up here. So you can have many features. You have many features. This is not one presenter, but many presenters. There's this Halloween theme, Halloween. Okay, so should it be one of your features? Yeah, okay, you have to make a judgment. But the thing is, you don't have to watch the video from start to end. You don't. You just have to go through some things over here and some things down here. 0 comments. And because I'm not signed on. So many views streamed 3 days ago. 3 days ago. Okay. Now I think I can make one allowance in your group project, which is, I think I didn't make it too clear in the instructions. Let me download it. Now, I say avoid including videos. Okay. I think it's better if I change it to and instead of or. Okay. Now, you have to use some judgment. You have to use some judgment. $1K. How many views has that video obtained? 124, 3 days ago. Okay. Now, mind you, these are just noise. Okay. You do not need to be too concerned with this. But I'm saying some like outliers. Okay. If it has over, let's say 900 views, okay, in only 2 days, should you include it? I would include it. 2 days, 900 views, not bad. Not maybe it has something important that we want to learn, right? Okay, so it's your judgment. It's your judgment. I said avoid. I'm not saying that you must not, or I will fail you. No, it's not like that. Okay, if you use your judgment, if you think I have something important to learn, if you think it would be one of the support vectors, then include it. Okay. So it was a part of a live chat. Okay, it was streamed. So is it part of the features? Maybe. But is it, if only have few videos like that, then probably it's not an important feature. Again, you have to make the judgment call. Okay. Now,
please welcome Andrew Ng.
Now, Andrew Ng has a lot of good videos, okay, on YouTube. He was teaching in some universities. But the thing is, you don't have to judge his videos. You don't have to, now, first of all, look at this video. Look at the title. It doesn't qualify. It doesn't qualify, right, in our group project. It doesn't even qualify. But let's say if the title says something about generative AI, then you have to look at all the features. Is this guy a feature? You be the judge. If you look at a lot of Gen AI videos and this name comes up a lot, then maybe it is. Now, but look at these 5,000 movies. Data. Do we have characters in here? We don't. We don't have Zhou Renfa or Liu Dehua. We don't have those things. So again, you have to make the judgment. You have to make the judgment. Okay. So that's now I think I have to leave it some time to you to understand the program, or you may want to have some time to discuss with your group mates. But I think there's something else we need to change here, right? Oh, search for documentation on random forest regressor. So let's do it. Let's do it. So another tab. So search for this. Okay. Let's just do this. Oh, by default, it goes scikit-learn. It goes to the top. And let's look at the syntax. Oh, sklearn ensemble, random forest regressor. okay, you have to, now actually it looks like there are no required parameters because this is a default. Okay, everything else afterwards are keyword only. Okay, is there an example down below? This is an API reference, so I will not be surprised if I do not find a, and actually there is an example. Maximum depth is 2, random state is 0. Okay, so let's try it. Okay, there's something you may want to try for your group project as well. Modify the program to use this algorithm and compare the results. Okay, let's do that. Now, because we have done this and we want to save it, right? So let's save this. This is my answer, for example. My answer. Okay, and then I want to save it as another thing. How about save copy? I do both at the same time. I create another one and call it random forest, right? Random forest regressor. Okay, and then you can try to change this file. Okay, so you have to import. You just follow the example, and this is how you learn. You have to make a regression and then do this. Okay. So let's try. You can click this and copy everything, or you can just select some text and copy here. Okay. So do we have to create a random forest first? I'm not sure. Okay, I'm also learning. Okay, so we're going to replace it. So the k4 is still the same. So I have the model. I don't change anything else. Of course, this one is no longer and neighbors. Okay, now I may run into some errors. Okay, but syntax-wise, it seems to be okay. So let's run it. It runs without problems. Okay, so now you can compare the two. This is the random forest regressor results. So I copy into this notepad. This one compared with this one. So the average seems to be better. The average seems to be better. Okay. The problem is that now if we predict on the unseen data, the error is the same. And the prediction, interestingly, is the same. Oh, why is it exactly the same? The model. The final model. Oh, because we haven't changed this. Good point. Good point. Oh, oops. So we should. Very good point. Now, this is how you troubleshoot, right? Okay. So let's run it again. Now, that's why we want to save our model, because it takes some time. And we are lucky because it only takes less than a minute. Wow, this model is not so good. This is random forest regressor. And the average root mean square is this, and the prediction. Now we don't know. The first row, this is suppose the first row. Okay. Now let's take a look at the actual data in X. The revenue, oh, we have to look at the Y actually, because we look at predictions, right? These are features. Let's look at the Y. 2787, 2787. Okay, so which one does a better job? I think this one, closer to the truth. Closer to the truth, right? Okay, so you do similar things in your group project. You try different things. Of course, I asked you to explain something, right? So in your group project, besides presenting me with the results, you have to show me that you have learned how to learn. You have learned how to learn, and then probably you want to get some explanations on this random forest regressor. Now, one special thing you note is that it says it belongs to the sklearn ensemble. Now, what is ensemble? Now, with today's AI, there are many ways to learn, okay, but I will learn it the old-fashioned way. You can copy it. And again, you can search for it. Okay, now this time you may not be going straight to sklearn. They are, let's say this one. This may be an interesting explanation. This is something interesting. Okay, there's some explanations here. Some visualization, features importance. Oh, this is same data set. This data set should look familiar, right? Is the California or Boston housing data set. Okay. There's some pros and cons. So you can find out something about the random forest model. There are some pros and cons. Okay. Okay, of course you have to cite the source of these references. Okay, that's different homework. Okay. So what is a random forest anyway? So you can, again, you can search for, because the random forest regressor, right? So it comes from random forest. Okay, and then you have some, now, I don't recommend you go for the AI. How about you look at some images? Oh, random forest, very interesting. So that's it. So basically, that's how you use some machine algorithms to predict something about some movies, okay, and then search for additional information. So I will stop here and then see if anyone has any questions. Today, good news, no submissions. I know everyone is busy, and I now make good use of this time to discuss with your group mates, okay, about the group project. Now would be a good time to take attendance.